Hello, dear students, how are you? I hope that you are all fine for today. This is Ms. Isra Saad from Science Team at New Generation Language School. By the end of this video, students will be able to know the concept of livers, fulcrum, and the factors affecting livers. So, our session for today is about law of livers. Last session, we talked about the livers, and the livers are a rigid bar straight or curve that rotates around the fixed point called fulcrum, and it's affected by resistance force and effort force. So our session for today is about law of levers. Law of levers states that effort force times its arm equal resistance force times its arm. Again, law of levers states that the effort force times its arm equal the resistance force times its arm. So from the previous information, we can mention the following important points. Number one, effort force arm or force arm. Both of them is right. Effort force arm or force arm. It is the distance between the effort force and the fulcrum. Number two, the resistance arm. It is the distance between the resistance force and the fulcrum. It's so easy. Again, the effort force arm or the force arm, it is the distance between the effort force and the fulcrum. Number two, the resistance arm, it is the distance between resistance force and fulcrum. And now it's your turn. The question number one for Noor Walid. Mention the importance of livers. And the question number two for Malak Ikromi. What is the meaning of livers? And you have 10 minutes start. 10 seconds, I'm sorry. 4, 3, 2, 1. Super excellent, Malak and Noor Walid. You're amazing. Okay. And now we are going to talk about the law of levers and the conservation of effort. First, the first class lever. There are three possibilities in this type of levers, which are: number one, the force arm is shorter than the resistance arm, so the effort force is larger than the resistance force. So the result is the first class lever is in this possibility doesn't conserve. Conserve means save, doesn't conserve or doesn't save effort or has no mechanical benefit. Again, look at this, or look at the first picture here. We have the fulcrum between resistance force and effort force because it is the first type of levers. But now look at the force arm and the resistance arm. The force arm is shorter than the resistance arm, so the effort force is larger than the resistance force. So the result is the first class lever in this possibility doesn't conserve or doesn't save effort or has no mechanical benefit. Number two, look at the resistance arm and the force arm. Yeah, excellent, excellent, super Zaina. Zaina said the force arm is equal to the resistance arm. So the effort force equal to the resistance force. You are amazing, Zaina. So the first class lever in this possibility doesn't conserve or doesn't save effort or has no mechanical benefit. Okay, and finally number three, Rimas said the force arm in this picture is longer than the resistance arm. So the effort force is smaller than the resistance force, so we can note that the first class lever in this possibility conserve or save the effort or has a mechanical benefit. You're amazing. And now we are going to talk about the second class lever. Second class lever. This type of levers always saves effort or has a mechanical benefit. Why? Give reason. Because the force arm is always longer than the resistance arm, so the effort force is always smaller than the resistance force. So this type of levers always saves effort. And finally, number 3, the third class lever. This type of lever doesn't conserve effort or has no mechanical benefit. Give reason: because the force arm is always shorter than the resistance arm, so the effort force is always longer than the resistance force. Excellent. So we get from the previous information that when the force arm and the resistance arm are equal, the effort force is equal to the resistance force. And when the force arm is longer than the resistance arm, the effort force is smaller than the resistance force. And when the force arm is shorter than the resistance arm, the effort force is larger than the resistance force. And notes: the effort force and the resistance force are measured in Newton. The force arm and the resistance arm are measured in meter or centimeter. The factors that determine the values of force and resistance are the force arm and the resistance arm. And I think that's enough for today, and thank you so much. See you later. Goodbye.